Good evening. I'm Tyler Corbett. All right, I'm going to be giving a presentation on programming and their applications. All right, I've simplified this so it's not going to be like a bunch of gibberish that you don't understand. We live in an era now called the Silicon era, or Silicon Age, the information age. And we're surrounded by technology everywhere. Instead of using a chalkboard, we went from that to a projector screen, as you can see. About 84% of U.S. households, according to the American Bureau of Census, reported to owning computers. 74% of them have internet access. 90% of U.S. adults have cell phones, and 58% of them have smartphones. All right, all these things, without programming and without a programming language or core structure, would just be very expensive paperweights. Right? So any kind of device, really, as you can see up here, whether it's a simple cell phone or it is the internet, game console system, manufacturing robotics, to a calculator, your thermostat, it requires some sort of programming, some sort of input computation. So the most minimalistic programming to complex programming. So, being said, we're going to go over four key things. We're going to go over historical accounts of programming, dating back to 200 years, just a few of them. We're going to go over machine language, or computation, otherwise known as binary. I'm pretty sure you guys have heard that, zeros and ones. We're going to go over the actual programming languages, which we use to program computers, versus having to type it out in zeros and ones. And then I'm going to show you guys some references where you can go to learn some more if you want to. So first of all, Charles Babbage in the 1800s invented a 15-ton machine. It's pretty much a 15-ton calculator made of 25,000 parts. Okay. The difference engine, the first one, didn't work. Pretty much a waste of time. Then he came up with another one called the analytical engine, and all it did was basic stuff a calculator can do. 1 plus 1, basic arithmetic. But then Anna Lovelace, probably the first programmer ever, came along and assisted him with programming the machine using punch cards to actually return the value of an algorithm. So it's a major change, and she's probably one of the first programmers ever to exist. All right. Then came Mr. Alan Turing. So if you guys have taken philosophy here, or maybe you guys have read, I think there's a new movie that just recently came out that focuses on him and his story. He invented the Turing machine. All right. And the Turing machine is a little bit more complex, a little bit more modern. It uses a reel of tape. Theoretically, it should be infinite, but here it's a reel of tape. And it uses a head. All right. On the tape, it has different kinds of cells. Here it's marked using zeros and ones. He had colors. They had values. So it would read and write across left and right on the tape, and whichever cell it landed on according to the value, it would do something. It would either stop, or it would change the value. It would move left or right until it halted completely. Then over here you can kind of see a different kind of artist rendition of how it actually works. You can actually refer to that as a cursor if you wanted. But then, in the late 1900s, came the digital computer, or the electronic digital computer. All right. It used electricity and it ran off binary. All right. Binary language is machine language. All right. Binary is data. It's stored as bits, bytes, bunches, kilobytes, megabytes, gigs, whatever you want to call it. This was we're most commonly familiar with. All right. So these digital computers, they use machine language. Okay. This is all that you see when the computer functions. Okay. It renders this. All right. How does it render this? Well, because somebody tells it to do it. It's instruction. All right. This is actually a program you might have seen when I first came here in my introductory speech that I wrote myself. All right. And I'm going to briefly explain to you how it works. So the programming language is called Java. All right. There's many different types of programming languages out there. I'll show you here after this slide. This right here, in the integrated development environment, which is pretty much an app that translates meaningful information to mean, which is like words, sentences, and stuff like that, numbers and numeric values, to machine language. All right. So what does this app do? How does it work once I compile it, once I run it? It pretty much gives me a graphical interface. It gives me my keyword, it gives me a button, and I can ask it some questions, okay? And pretty much the only feature I'm going to show you here is how it remembers who I am. All right, ask it, who am I? It doesn't know. That's the default, okay? It's a default value. So I tell it who I am. I'm Tyler. And it asks me, you're Tyler, correct? I say yes, all right? Then finally, it says, okay, who am I? You're Tyler. So it's very simple, all right? I give it some instruction, tell it what to do, I tell it how to do it. I use a computer with hardware, and in the end, this is what you get. It's a basic little simple app. These are all the different kinds of programming languages out there. There's many, many more. Okay, they're all what's called object-oriented. Pretty much, these applications, they help the computer create real-world model objects, things like a square or a pen or something like that, and you define it. So that's how we end up getting, Windows, and we can actually click widgets and buttons and things like that of the sort. Okay, over here is Java. Over here's a different kind, it's Python. They just look different, they're formatted differently. There's Ruby. All right, references, where you can go to learn these things, or excuse me, these are ways you can program, okay? Python anywhere, you can do it anywhere online, it's in the cloud. Okay, there's Eclipse, Android Studio, you can even program with Wolfram if you like. Use your trials. Aid, right over here. The ID for Android is how I made that one app I just showed you. And these are the references. Learn Java, you can go to oracle.com. Code Academy will teach you for free. Very basic, simplistic stuff. You can learn Java. You work actually HTML, I believe. You can learn HTML. All right, Aid, again, what I use, it actually has integrated tutorials in the application. Wolfram, again, most popular for its database search and queries and stuff like that, like Wikipedia. The only difference between Wolfram and Wikipedia is it doesn't search all the other databases on the web. Wolfram actually computes through its own database, and it computes your query instead of searching, which I find that amazing. Khan Academy, everybody learns how to, they go here to reference for math. You can learn pretty much anything on Khan Academy. They also teach coding. All right, and then Python, you go to the website and learn that as well. So, to end, we've come a long way. 200 years back, we came from a 15-ton calculator to a computer that could pretty much do anything and handle our entire life in the palm of your hand. All right. Right now, programmers helped program the robot rover on Mars, Curiosity. It runs autonomously sometimes, and sometimes it receives instructions from us. It wouldn't exist, it wouldn't be able to do its job unless somebody gave it instructions through programming. All right, programs and software also help decode the human genome for the first time, I think maybe like 10 years ago, which is incredible because the thing is huge. It would take you, I think, almost an entire lifetime to write it out by hand. Programs in a matter of weeks. And right now, most recently, I actually saw this in the Time magazine. This is the first quantum computer ever to exist, as far as we are concerned. The temperatures that they store, the actual processor, and all the little guts of the computer is stored at 490 degrees below zero, which is the coldest place we've ever seen in the universe, to be honest with you. So we're curious, and I'm curious to see what this kind of thing can do once provided instruction. So, and that being said, we'll see what kind of information, what kind of jobs that this quantum computer can soon do. And last but not least, I was talking about the application that I made earlier. Clash of Clans, according to Business Insider, which is that simple, stupid app that everybody plays. I hate it. But back in October 2013, in one day, they made $654,000 in one day. So anybody, really, it doesn't matter who you are, you come up with something brilliant, and you put it in code, and then you run it through a computer, and somebody else likes it, and they sell it for you, and then you're rich. Or maybe you'll find, or you'll compute a cure for cancer one day. Who knows? That's all I have. Thank you.